accessible to you no matter where you are. There's lots more information about how to watch an eclipse. Again, that website address is eclipse2017.nasa.gov. It's the only time that's safe to take these glasses off when you're looking at the eclipse is if you're in the path of totality during the brief few minutes that the moon completely blocks the sun. Let's watch this video to learn more.
On August 21st, 2017, the Earth will cross the shadow of the Moon, creating a total solar eclipse. Eclipses happen about every 6 months, but this one is special. For the first time in almost 40 years, the path of the Moon's shadow passes through the continental United States. Everyone there will see the Moon at least partially block the Sun. People within the path of totality, shown here in red, will witness a total solar eclipse. For them, the Moon will cover the Sun entirely. The sky will become twilight, the air will cool, the stars will appear, and the black disk of the Moon will be surrounded by the pale, streaming halo of the Sun's corona. Totality will last for 2 minutes or a little more, and it will be visible along a swath that crosses the continent, from Oregon to South Carolina. For some, it will be the spectacle of a lifetime.
Coming up during our 1 p.m. broadcast, we will have a live demonstration with a pinhole viewer and more ways to safely view today's eclipse.
NASA TV is going to be bringing you real-time, breathtaking images. In locations across the country, we have cameras and telescopes and balloons and aircraft and even spare spacecraft standing by to bring you views of this natural phenomenon.
Got it all. I can't wait. But right now, let's take a minute to learn about one of the aircraft being used today. NASA's Armstrong Flight Research Center operates a Gulfstream 3 airplane for aerodynamics research and mission support. Today, their flight path is taking them over the Pacific Ocean to see the very first view of the total solar eclipse as it begins to cross the country.
Let's watch this video to learn more about their eclipse mission.
NASA's G3 aircraft out of Armstrong Flight Research Center will feed the world live video coverage of the eclipse from the west coast of Oregon as it begins its path across America. So we hope to bring that view through the eyes of NASA. We go out there and modify aircraft all the time so we can go out there and do NASA science. It's what we do. In the case of this aircraft, we've gone out there and taken the normal passenger windows and replaced them with optical grade windows, plus put in a telemetry system so we can go out there and provide real-time video. With these optical grade windows, it allows our photo and video teams to go out there and capture high-resolution video at 35,000 feet to present to the world this rare event. And using this event to go out there and educate people, I think, is an exciting proposition.
All right, it's just about to turn. We'll be almost.
From a pilot's perspective, we want to make sure we get to the right spot, and also there are limitations for what our photographers can do.
Roll out here.
We pushed it as far west as we could go so we could get that as early as possible and as low in the horizon as possible. And that put us at about Lincoln City, Oregon, which is the farthest west point right on the west coast. So we set up a holding pattern or a racetrack pattern right over Lincoln City. We know exactly the width of the totality swath. With that, we did some mission planning again to make sure we know what the stall speeds are, the slowest speeds, the safest speeds to fly, the speeds that will give us the most time inside the totality region. We can slip the airplane. That'll give us some more bank angle, which lets our cameras see a little bit higher. So all of those kinds of things were what went into from a pilot standpoint, planning this out.
All right, you guys ready to turn in again for a partial?
I think it makes us proud of what we do and that we're able to share it with everybody around the world in this case, due to the modifications to the airplane we made. That's what we do.
How you doing, Cope?
Great.
Wow.
I can't wait to see what that G3 is going to show us today.
That was amazing, and it's going to be an incredible view, the first view of the solar eclipse as it's literally crossing into the United States.
So basically it is off the west coast right now, so it's getting a view of the eclipse before we even get a view from land.
Right,
of
right.
That partial eclipse.
And that G3, it's just one of a fleet of NASA aircraft and observation platforms that we have. We've got, as we mentioned earlier, satellites, both ours and some of our partner agencies, aircraft, the balloons that we've got, and we'll be telling you more about that in our 1 p.m. Broadcast as well. But we've got you covered here. It's in terms of, eclipse, not only looking at it from the ground, looking at it from the sky, looking at it even from space. I don't know if we can get a little preview to that.
Great. You know what I just heard? We've got the Salem, Oregon eclipse starting.
Wonderful.
This is the partial transit, and we're going to the G3 now to see what they
Live
can
to the
see.
G3.
We've got an exclusive feed as they fly over the Pacific Ocean, and Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Do we have Kevin?
Okay.
All right, he's going to be up soon.
But you can see, and we actually have a monitor here on set in Charleston, so we can actually see what they're seeing live, and you can see the transit beginning as the moon is just starting to eclipse the sun. Isn't that an incredible image, Karen?
No, it's beautiful. And so just to be clear, what you see on the screen right now, right, is that partial transit. The partial transit can take, the partial eclipse can take, up to 3 hours, a little bit longer in any one location. Whereas the total eclipse, that's only about 1.5 minutes, 2 minutes.
Right. A lot of people talk about the totality, only lasting maybe at most 2 minutes or so. But sometimes people don't realize that in terms of the entire eclipse, from the very beginning of when the moon starts to cross over the sun's surface till the end is actually much longer.
Yep.
Okay.
Great. So let's talk a little bit more about these eclipses, because I want to tell you one of the things that I think is one of the cool things about total solar eclipses. We're the only planet in the entire solar system that can see them.
The only one.
The only one. Earth is the only planet where the moon appears to be the same size in the sky as the sun. And that's really just a great cosmic coincidence.
That's right, Karen. The sun, believe it or not, is about 400 times wider than the moon, but it's also about 400 times farther away. Now that geometry means that when they line up just right, as they are today, the moon blocks the sun's entire surface, creating a total solar eclipse. Let's take a moment to learn more about that geometry.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every 1.5 years somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. It has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
Wow, that was amazing. So now we've got a live shot from that G3 aircraft looking out the window as the eclipse begins.
We're going to be seeing the eclipse live from this G3. It's 35,000 feet up in the air.
Over the Pacific Ocean as the eclipse begins. Very interesting to see how they had to sort of retrofit it with the special glass to get the best viewing possible. And I'm sure it's an exciting moment up there. I can only imagine what the folks inside the G3 are feeling right now.
Great, and coming up we will have some live interviews from the G3. And now we are once again looking at the eclipse from Salem, Oregon. So to all the people who are out there in Oregon, this is what they are getting to see right now, that first little glimpse of the moon. It almost looks like a bite out of a cookie, right? A little first glimpse of the moon passing in front of the sun. Now Salem is in the path of totality, so they will have a chance to see the full eclipse.
And they've got great weather from what I can tell, and certainly a good shot from this telescope there on the ground looking at the eclipse. It's amazing. And just a reminder for folks, we can't say it enough, stress it enough, the safety aspect. If you are anywhere, whether in the path of totality or not, you've got to have those glasses, even if you're looking at a partial eclipse, even if it's cloudy. All right. When depicting an eclipse path, data visualizers have traditionally represented the moon's shadow as an oval.
But for today's eclipse, for the first time, NASA visualizers were able to show that the moon's shadow is actually better represented as a polygon. And this more complicated shape is based on several NASA observations, including information from NASA's Lunar Reconnaissance Orbiter, which is currently orbiting the moon as we speak right now. The spacecraft has a unique view of the mountains and valleys that form the moon's jagged horizon.
Let's learn more now about mapping today's eclipse using NASA's unique data sets.
What we're talking about is several visualizations of the path of the moon's shadow during the eclipse in 2017. Everything in it is driven by the data. So the color of the ground, the position of the path of totality, the lighting from the sun angle, all of those are things that are based on data. A lot of NASA products were used to create this visualization. I used the Lunar Reconnaissance Orbiter, the laser altimetry data from that, which gives us a digital map of the elevations on the moon. For the Earth, I used something called SRTM. This was a radar that was flown on the space shuttle. For the positions of the Earth, the moon, and the sun, I used a JPL ephemeris. An ephemeris is just a list of positions, but it's the most accurate tabulation of those positions. This visualization is unique because it shows the effect of both the irregular edge of the moon, the limb of the moon we call it, and the elevation of the observer. Now, we've known for a long time that the elevation of the observer affects where the shadow is. We've also known that the mountains and the valleys along the edge of the moon affect the shadow. So you may have seen on eclipse maps in the past that the image of the umbra, that shape of the shadow on the Earth, is drawn as a smooth oval. But we know that the moon isn't smooth. Around the edge of the moon, we have these sort of jagged peaks and valleys. And a peak can block the sun a little bit earlier than you thought, and a valley can let the sun in a few seconds longer than you thought. The combined effect of these peaks and valleys is to create a shape that's not really an oval, it's more like a polygon. But it hasn't actually been seen in exactly this way before, where we calculate those circumstances for every point on the map and draw that shape. Totality is that 2 minutes when or 2.5 minutes when the moon completely covers the sun. The sudden darkness of totality is just something that a lot of people can't compare to anything else. I love the idea that I'm giving this kind of map to other people, and especially that it's more detailed and more accurate so that people are actually in the right place to see it.
So there's a lot of great science being done today, and this eclipse provides an opportunity for researchers to test innovation for future NASA missions too. NASA scientist Nat Gopalswamy and his team pursue eclipses because when the moon completely blocks the bright light of the sun, it reveals the corona, which is our star's faint outer atmosphere.
And this year, scientists will test a special kind of camera. The team will only have 120 seconds to complete an experiment that may one day change the design of sun-observing spacecraft.
Let's learn more about how this team of NASA scientists is chasing the sun.
The corona can be studied from ground-based telescopes only during eclipse. When our eclipse happens, we make use of it and try to test some of our ideas.
Yes.
We have only 2 minutes to do the experiment, and we have been preparing for maybe more than a year.
Nothing can go wrong. Your camera can't shut down, you can't press the wrong button, and because there's no time to change your mind or make alternate decision.
We are going to set up the telescope and observe the total solar eclipse at 4 different wavelengths, and the images taken in these 4 different wavelengths will be used to determine the temperature and flow speed of the corona.
We are planning to take these images using a polarization camera, which will be a first for us. I think it's the first for the solar physics community. So once the moon completely covers the sun, the experiment begins. It's my job to make sure that the image is in the field of view. So at the correct time, one person has to give the command to turn the filter wheel, and for each filter there's a different exposure time. So another person has to enter the exposure time.
Running 3850 right now.
It's a combined effort of 6 different hands. No one person can make any errors.
8121. We do feel the pressure and also the excitement of the eclipse. Still, we have to focus on our experiment. Hey, all done.
It gives a tense feeling, but I believe we'll succeed.
All right, we got another beautiful shot here of Oregon, and we're getting ready to start showing you imagery from around the country.
That's an amazing shot. And right now, we're going to toss it to NASA Edge, who is standing by in Carbondale, Illinois.
Tell us a little bit about that, because if you've received social media questions about it, you have the data point to respond to that.
Yeah, you know, honestly, when I first saw the eclipse, before the eclipse, I was like, well, I've seen lunar eclipses, I've seen partial eclipses, probably similar in experience.
Looks like Troy's been a real eclipse traveler. I didn't know this about you.
I'm an eclipse chaser now. It's like, but it was the first one I saw was in Turkey, in Side, Turkey, and the next one was in Micronesia. And when the eclipse happened, it was about 85% coverage, as I could see with my pinhole projectors and my glasses. At about that moment, I noticed the sky around me started getting noticeably dark, and the temperature dropped about 10 degrees.
We could use it.
Oh my, yeah, we're totally going to love that. And at that, right as the disk of the moon covered the sun, it was phenomenal. You're overwhelmed with an amazing feeling of being connected to the universe around you because your vision is you're seeing things differently, the shadows are changing, the animals are acting differently.
Yeah. We know about that. I do want to take a quick moment to say that welcome our friends from NASA TV who are joining us from Charleston. Hope they have clear skies there. We clearly are having clear weather here.
We're having clear weather.
A little bit of clouds, but easy to manage. Great to have you guys joining us. Now, like I said, you have time to check this out, to see these sort of eclipse views. What other strategies could you share with our fans to prepare for the eclipse?
Just to basically, when the eclipse happens, spend all of your time with all the different devices and pinhole projectors before and after totality. The biggest thing that I would recommend is when totality happens, unless you have a camera set up on automatic, don't miss a second of the event. Make sure you are looking at the eclipse. Now, one of the things, some people forget to take their eclipse glasses off during totality, and they miss the whole thing there because they think it's unsafe. But you're not actually looking at the sun during totality. You're looking at the backside of the moon, which is pretty dark.
Yeah.
I mean, it's the darkest blackness you've ever seen. And at that moment, you will see the corona of the sun just magically appear across the sky, and you'll see several stars today. I think we have M planets, so we have the potential to see 4 or 5, I believe, planets and stars.
Okay, but you have to be pretty strategic at that point, right?
Yeah.
Because that's during totality.
That's during
totality. So you got to get your solar experience, and then you got to swing your telescope around, or will you be seeing them with the naked eye?
You can see it with the naked eye during totality. Perfect. I recommend everybody look at it with the naked eye during totality.
Perfect.
But as soon as one bit of sunlight starts to come around the sun, trust me, it is super bright, and immediately put on those glasses and start using your pinhole projectors again.
That's a great point, and it's awesome because we're getting lots and lots of good science and good observational data to prepare everyone for how they can experience the events.
And you know something I have to tell you, we have a Flickr gallery that people are uploading many pictures to right now. We would recommend and highly recommend that you go to the eclipse2017.nasa.gov site. You'll see the Flickr links there, and these beautiful images that you're seeing right now are images that were already uploaded just over the last several days.
Well, what's interesting is it's not just photos from previous eclipses. We're seeing lots of artwork, lots of really creative work. I think that's spectacular and a great part of what's going on during this eclipse.
People of all ages are ready for this.
It's fantastic. Well, I'll tell you what, Troy, thanks so much for coming on. When we come back later, you're going to share with us the results, right? And we're going to talk about that, right?
That's right.
And get more questions. Great. Well, right now, we're going to go inside the stadium to Kevin Boucher, who's with Greg Guzik from the Louisiana Space Grant Consortium, and they're going to talk about this balloon launch that they're going to provide for us. So take it away, Kevin.
I sure will. Thank you very much, Blair. Again, we are standing on about the 30-yard line in Saluki Stadium, and of course, the stadium is filling up. And with me now is Dr. Gregory Guzik. And introduce yourself. Who are you with?
So my name is Greg Guzik. I'm a professor of physics in the Department of Physics and Astronomy at Louisiana State University. More importantly, I'm actually the director of the Louisiana Space Grant Consortium.
Okay, now what is that consortium? Who is it composed of, and what is its mission?
So the National Space Grant College and Fellowship Program was established by Congress in 1987. It's a nationwide effort. Every state in the Union, plus Puerto Rico and Washington, D.C. has a consortium. And for this project, there's a team, a collection of about 55 student teams placed from Oregon to South Carolina who are going to fly balloon payloads very similar to what we're going to fly here from Saluki Stadium.
And when I think weather balloons, I have this image. I think of one of my old Time Life series of books. The National Weather Service was launching a monstrous balloon. This balloon that in my memory was like 100 feet long, but yours are a little bit different. Can you talk about the structure of these balloons?
So these are normal balloons that the Weather Service actually uses, hence the name weather balloons. They're made out of latex, rubber. When they're fully inflated here on the ground, they're about 8 foot in diameter. And as we go up in the stratosphere, they'll expand to about 40 feet in diameter.
Okay, and if I believe right now on your television screen, I think you are actually seeing some data and video from these weather balloons. Oh, also earlier you told me you've been...
All right, thank you, NASA Edge from Carbondale, Illinois. I know you guys were asking about the cloud cover here in Charleston. Unfortunately, it is starting to increase as predicted. I don't know if you can see it over our shoulders here, but it's pretty cloudy right now. But that has not done anything to the enthusiasm of the crowd that's building here.
And now we've got that G3 aircraft, the one we talked about earlier. It's ready. They're 35,000 feet up and ready for us. We have an exclusive feed as they fly over the Pacific Ocean. Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Kevin.
She's pausing. Hi, welcome aboard. We're on NASA Armstrong's G3 aircraft right above the Pacific coast. I'm Kevin Rohr, and I'll be your host on the aircraft. And a big howdy, and thanks to everybody on the ground that's making this shot happen. We've got a fantastic look out the window right now. We're circling above Lincoln City. We got a little bit of cloud cover down there, but we're going to have a fantastic view of the eclipse, and this should prove to be a wonderful day. With me today is Robert Lightfoot, Administrator of NASA, as well as Dr. Zabukin, Head of Science. And what we're going to do is cut to them really quickly so we can have a little discussion. And what are your impressions today, Robert?
Thanks, Kevin. What a great morning so far over the Pacific Ocean. We got to see the first bites out of the sun from the moon. Just an incredible view so far. I really want to thank all the teams that are out there all over the country helping us to get the most science we can get from here. Really going to be an inspirational day and hopefully inspire the next generation of scientists, engineers like me even, in the current generation. Pretty inspirational from that standpoint. Volunteers everywhere, so we're excited about what's going on. And I got to turn it over to my buddy Thomas here. This is his field of study. So Thomas, what do you think so far?
Oh, it's amazing. We're already seeing it happening, right? Why do you think this is important to NASA and the United States?
Well, for us, it's a great opportunity. The totality across the continent, we're going to learn as much as we can. We study heliophysics and astrophysics in NASA, and this is a great opportunity for us to learn even more and have every instrument we have out there available to us to try to understand what we're going to see for the first time in 99 years. So just very, very exciting to see what we can do here and the observations that we're going to get. Can't wait to see the science come in and all the different science we're going to get from here. So, everybody's going to learn something. So you tell me what you think you're going to learn, Thomas, having been studying this for your whole career.
Well, look, my field of study is the sun. And what's really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun, during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars, we learn here first. But it's also a source of weather and radiation. And actually on board this aircraft we have two instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, and I think it's important. The more we know about the sun, the more we know about space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event.
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by applied physics lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here. On the G3, can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has two predominant lines. One is really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are about 30 minutes away from totality. But explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes affects the Earth and its turbulence. And, I mean, I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
Wow.
And that's
It's
great.
amazing, yeah.
Thank you to those of you on the G3 to fill us in on what you're going to be seeing from there. Here we are on the other side of the country, here at Charleston, South Carolina. I want to give a shout out to the college. The students here have been so incredibly great for us, and we are actually going to have a chance to go back to Salem, Oregon, and find out a little bit more about what they are seeing there. They're talking about this moon picture right here.
Right, we've got a live picture right now from Salem, Oregon. We were showing you earlier in the broadcast, and as you can see, as we've been sort of describing it as the moon taking a bite out of the sun, it's continuing to happen, and what it looks like, Karen, is like it's almost like the sun. What we see is almost like a crescent moon, but it's not. It's the moon is actually the black portion in the upper right-hand portion of the sun that's being blocked out as we get closer and closer toward totality, which. As Robert and Thomas said from the G3 aircraft, is only about 30 minutes away for folks in Oregon.
And we will go right to Madras, which is right near Oregon. This is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, you know, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks, we're talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as they mentioned earlier from the G3, about 30 minutes from now to totality there, about 90 minutes to get to where we are here in Charleston. So that means what? If time's right, in about 2 hours, we'll be at totality here.
And we are now going to go to Salem, Oregon, where Jesse Carpenter will be talking to Nikki Weil, a solar scientist from NASA.
Welcome back to Salem, Oregon. It is clear, but yes, it is a little bit breezy here today.
It's windy, yeah.
Isn't it? Yeah. I'm joined again with NASA solar physicist Nicolene Weil.
Hi.
Hey, so why don't we just take a look at what we've got going on here now that transit is deep underway.
Yeah, so the moon is crossing in front of the sun, and it's kind of looking like the moon is taking a bite out of the sun. And if you guys have any colanders with you, like a kitchen colander strainer, you can actually see, if you let the sunlight come through that colander and look at the shadow on the ground below you, you'll actually be able to see the projected image of the moon taking a bite out of the sun down on the ground in front of you.
Oh, that's cool.
Yeah.
So you can just get something from the kitchen and share that with everyone who you're watching this with. That's great.
That's right. Now's the time to take out your pinhole cameras if you have those, or if you have those, the safety eclipse glasses. Now's the time to get these out and make sure to look at the sun with these on.
That's right. You want to be watching safely. And I know we've been talking about it, but we really can't stress it enough. It's very important to be wearing these glasses.
It's just so amazing, though, to see the moon crossing in front of the sun. I mean, you never get to see anything like this.
So, are there some basics that you could share with us? I know we were trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So there's sort of three outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the atmosphere, the chromosphere and the corona of the sun. And we don't usually get to see those because they're so much less bright than the sun. It takes something special like today's total solar eclipse to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool. So I think what we're going to be doing now is sending it back to NASA's Eclipse Central in Charleston. Take it away, guys.
Thanks.
And welcome back to Charleston. You can hear these students are really excited for us. And I gotta tell you, I had the chance to interview some of them just a few days ago. The College of Charleston students are excited, and I wanted to find out what they knew about the eclipse. Let's watch the video.
All right. So right now what we're looking at on your screen is
Hello, I am Karen Fox with NASA TV. I'm here at the College of Charleston in Charleston, South Carolina, and we are going to spend some time interviewing students to find out what they know about the total eclipse of 2017. What's happening on Monday?
The solar eclipse is happening.
Monday, the eclipse.
That's the right answer, the eclipse. Are you ready for the eclipse?
Oh, I'm pumped. I've been talking about it all summer.
What is an eclipse?
When the moon moves in front of the sun.
It's when the moon passes in front of the sun and creates a shadow on Earth.
What is the closest star to Earth?
The sun. The sun.
The sun.
The sun? Yes, the sun. Very nice. Will you demonstrate for me putting these on?
We're going to put them over the glasses.
The music you associate with the eclipse. What have you been listening to? What are you going to listen to?
Here comes the sun.
Total eclipse of my heart.
Do 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 do.
Da-na-na, like I saved every letter you wrote me.
So I was really impressed with how much these students knew. We had a great time here. And now you can once again see the imagery we are pulling in of a white light telescope of two eclipses happening as we speak. These are again the partial eclipses, Salem, Oregon, and Madras, Oregon.
Right, as you can see, it's quite an image as that moon continues to progress. Transit is the term over the surface of the sun, getting closer and closer toward totality. And again, this is an opportunity for us to remind folks, regardless of whether you're watching this right now in Oregon or if you're anticipating the beginning of the eclipse from another location in the U.S. or really across North America, wherever you're able to view us from, that it's important that you have to have those safety glasses. We cannot stress that enough. We've been getting a lot of questions on social media, people just emailing us asking about that. You must have the glasses unless you are in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Weil, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on a tree. There's some really wonderful ways of catching imagery of it. So, be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little bit about the science that NASA's
We should, but
doing today,
before that, I just want to give a shout out to our website because you're talking about all these great ways to indirectly view it. And again, just a plug for the Eclipse2017.nasa.gov site where you can find all kinds of information, but especially some do-it-yourself instructions on how to create some of those indirect viewing methods.
Great, we've talked a lot here about the partial eclipse. Nikki Weil, who you just heard talking, she studies the corona, that is the atmosphere around the sun. And she was telling me just the other day how excited she is that she is going to be able to see that with her naked eye during the actual total solar eclipse. So that's what's interesting. We can only see that normally from space with our space telescopes.
Right, and even with that, I was talking to one of the heliophysicists back at NASA headquarters in Washington, D.C. Recently about this, that even with those artificial eclipses that they create from the coronagraphs, they're called, in space, it doesn't give you the same viewing opportunities that we have with a natural eclipse like we're seeing now. That there's actually a couple different layers of the sun's corona. We have the outer corona and the inner corona, and because of the way those coronagraphs work, they do not allow a good image of the inner corona, the part that's really close to the sun's surface. Only the outer corona. It's only during an actual natural total solar eclipse like we're viewing today across the country that scientists, heliophysicists, and others, and just the general public are able to see the entire corona, and that really gives them a lot more information. And remember, for these scientists, no matter where they are, they only have that brief, maybe 2 minutes, maybe 3 if you're really lucky, right in the center line of totality, to see the entire corona and get those measurements.
Yeah.
So again, Karen, as folks are looking at their screen right now, you see that double image, Salem, Oregon, there on the left, and nearby Madras on the right. 2 different images with 2 different types of telescope using to view this eclipse. It's still in the partial stages, starting to get closer and closer toward totality in just a few minutes.
And stick with us because we are going to be tracing this eclipse all the way across the country. Not only does everybody in the country have a great view, but we have some views from the sky, don't we, Sean?
That's right. Looking up from the ground is how most of us will experience today's eclipse, but researchers at Southern Illinois University wanted a different perspective. They wanted to look down at Earth to image the moon's shadow. In Illinois and across the United States, teams are using high-altitude balloons for a unique perspective.
Right now, they're getting ready to launch a research balloon from Saluki Stadium in Carbondale, Illinois. We're going to go back to Carbondale, Illinois. The primary payload will be a real-time, high-definition video system. So let's check in on the progress of that launch.
Holistic astronomy here, we're experiencing it on lots and lots of
Eclipse in 4D. It's just like being on the surface.
But, you know, to actually understand the corona is very important because all sun-like stars have their corona. We need to understand why the energy is released in the way it is.
All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
That is what's going to let that get safely down to the ground.
And all those instruments
strung out along there. Attached as well. That's a beautiful sight.
Okay, can you hear me okay, right? Yes. This is Kevin Boucher. Sorry about the little mix-up. I was too enthralled. I was too enthralled looking at this fantastic weather balloon that has just launched. You can probably see it behind me. It is pandemonium here, but it's good pandemonium. One of the weather balloons has launched, and with me is one of the team members. Introduce yourself to the entire world. No pressure.
Hi, my name is Colleen Fava. I'm the program manager for the Louisiana Space Grant Consortium based at LSU.
Okay, so just to kind of keep a scorecard for people if they're wondering, we talked to, I guess, the program director, Dr. Gregory Guzik. He is your boss.
Yes, he is my boss.
What exactly does your job entail with this consortium?
I manage the program, so I write grants and reports and organize students and keep them on track, and I do communications training.
Sounds like you do a lot of outreach as well, and it thrills my heart, and I'm sure it thrills your heart, to see so many of these young people. You probably did not have to drag these young people kicking and screaming to do this help, did you?
No, we brought 4 institutions with us, and LSU is the home team, and so they were always coming, but we actually had a competition to figure out which other students we would bring, and we brought a team of 46 people.
Okay, and right behind you now, I had forgotten they're launching 2 balloons. Now the first balloon, I think we have a video of the first balloon. Okay, we're getting ready to launch the second balloon.
Both of our balloons launched already. That's
Okay.
the balloon, another
The first balloon, Colleen, that was launched, where is it right now? Maybe 2,000 feet, you think?
They go up about 1,000 feet a minute, so a few thousand. It's probably been a couple of minutes now.
Okay.
So.
There it goes. This other one has launched. It's a big yellow balloon filled with helium. And the next time we see this balloon, we'll be down on the ground. It'll have wonderful data. Can you tell us about what goes into studying the winds and the weather reports, trying to calculate where this will land so you can quickly retrieve it and get your data? That's a whole nother science.
Yeah, so I'm not an expert on it. I can just tell you that we do our predicts. We started our predicts months ago, doing them maybe every week or so, and then the last few weeks we've been doing predicts every single day. So we have a good idea. We think it'll go about 36 kilometers, about 22 miles due east, somewhere near Marion. So we'll have several chase vehicles kind of staged and ready to go, and I'm not sure if they decided to leave before or after totality, but we have some local people helping us to make sure we have access, and we're hoping, expecting to be a pretty easy recovery.
Now, will you actually be on the chase team yourself?
No, I'm not going to be on the chase team. I need to do logistics here on the ground. I have been on a chase though, and it's very exciting.
Oh, I'm sure. Yeah, can you tell me about it? And please get as specific as you can. What are some of the most eventful ones? Like, has the balloon ever come down in
Pontchartrain River?
How did you know? You're not kidding me.
I'm not kidding you. We did have a landing in the Pontchartrain River, which was not a great recovery, but it was definitely better than landing in the airport, which we were afraid was going to happen.
Well, I was going to say I would rather land in an airport because the Pontchartrain River, you have the water that might damage some of your instruments, but you're the expert then, right?
I think we'd rather not interfere with air traffic control.
That's true. Landing in a Pontchartrain River, and I assume the alligators did not make a meal out of your several $1,000s worth of instruments?
We didn't recover that payload, but we have done water recoveries in the past, and we actually just invested in an inflatable kayak.
Okay. My producer just told me we are seeing first contact. Everybody, we have people putting on their glasses the first contact. We are seeing the first contact, and we've got about 4 minutes left. How many total solar eclipses have you seen, Colleen?
This is my first.
I assume you have your glasses. Right. Feel free to go ahead and put your glasses on.
You want a pair?
Yes, please.
Your fingers together, you can make little spaces in between your fingers.
If you don't mind, I'm gonna.
You can project little images of the eclipses down onto the ground. So make sure you look down just as much as you look up.
You can't really see through them.
Also, if you
Right. Okay. My glasses are on. Are your glasses on too?
They are on.
Okay. And the sun, we are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Oh, okay. I'm going to turn my back to the camera. Oh my gosh! There is a small bite starting in the sun. What are your comments?
I said that is gorgeous,
Because of
isn't
these
it?
ripply shapes you see on the ground.
That is fantastic. The total solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer, I can take these out. I will go to the solar, I think it's the Dynamic Observatory that often will give videos of the rotating sun. And Colleen, I don't know about you, but when I see that giant ball of gas just rotating, majestic is a word that comes to my mind. Could you agree?
I absolutely agree. It's amazing, and I think that we're really fortunate to have this opportunity and to be in community with our students and faculty and staff from multiple institutions here at SIU, who's been wonderful and very welcoming. It's just extraordinary.
It sure is. Thank you very much for your time. Keep up the great work. Thank you for talking with us. That was Colleen Fava with the LSU.
Thank you so much
Yeah,
to
thank you,
Carbondale.
Carbondale. That was amazing.
It's great, and I love looking at those images and how you can see different things at different parts of the country. It's wonderful to be sharing this imagery with all of you. We will have more from Carbondale later today. Please stick with us. We have so much coming
more.
up.
From there and from here at NASA's Eclipse Central here at the College of Charleston.
Looking out toward the horizon, we await the first glimpse of a total solar eclipse when the movement of our moon completely blocks our view of the sun. Starting in the air from NASA's Gulfstream 3 aircraft off the coast of Oregon, we anticipate this awe-inspiring celestial event. Over the next 3 hours, we will track the solar eclipse as it moves across the entire United States from coast to coast, observing this incredible event through the eyes of NASA. Hello and welcome. I'm Dwayne Brown from NASA's Office of Communications. And over the next 3 hours, we're going to look through the eyes of NASA and experience today's total solar eclipse. I have a great team here on stage. Joining me to my immediate left is Jadi Collado Vega. Hi, everybody. Who is a space weather scientist. Solar scientist next to her, Alex Young. Over to my right, John Yimbrick, who will be taking your social media questions today, plus media specialist and meteorologist, very important man today, I must say. Tracking the weather conditions across the path of totality, Sean Potter. Today we're coming to you from NASA Eclipse Central here at the College of Charleston. Now, Charleston is the last stop of the total solar eclipse on U.S. soil. So we will track this eclipse as it moves east and heads this way. We're tracking the eclipse across the entire country to bring you the best images with the most compelling stories, along with science experts. Here from NASA Eclipse Central, we have views from ground telescopes, high-altitude balloons, airplanes, and from several NASA spacecraft. And yes, and I want you to remember this, audience out there, we even have live, no one else, only here at NASA, the International Space Station. If you want to see the eclipse as never before, stay with us through the eyes of NASA on NASA television. This is the place to be. Yadi, hola, ¿cómo estás?
Bien, ¿y usted?
Okay, this is a win-win situation for America. We have a partial eclipse and a total eclipse. Explain the difference.
So today, pretty much the moon is going to come across the Earth and the sun. So North America, Central America, and parts of South America are going to see a partial solar eclipse, which means that the moon is going to partially block the sun. It's going to look like the moon took a bite of the sun, like you have seen on the previous images. A total solar eclipse is going to happen in a very narrow path, 70-mile wide, that comes all the way from Oregon, crossing the whole continent of the United States, and getting out here in South Carolina. You're going to see a total solar eclipse, which means that the moon is going to completely block the surface of the sun, and you're going to be able to see the solar atmosphere, the solar corona, with your own eyes. Day will turn into night, which means the stars and the brightest planets are going to come out.
Jody, Alex, you guys have been waiting for this for a long time, as all these other scientists around the nation. This is the day we've been waiting for, and we're here, Eclipse Central. You guys, if you're here, this is the place to be. We have remote NASA TV broadcast sites along the path of totality so that anyone watching along with us can also experience the total solar eclipse. We'll also share information about how to experience the eclipse safely wherever you are and give you a peek at all the exciting plans NASA experts have today. Alex, okay, so Mr. Solar Man, what is so unique about the solar eclipse?
Well, this is an amazing opportunity. The last time we had a total solar eclipse in the continental U.S. was '79, but the last time we had one that went from coast to coast was 1918, 99 years ago. So we are having a total solar eclipse that's covering a huge portion of populated, accessible land. This is giving us an unprecedented opportunity to study, to look at the impacts on the Earth, to see the corona, and give us science like we've never had before. I mean, the last time we had this kind of connection to where we are and who we are was actually really the Apollo 8 Earthrise. And that gave us a perspective outside of just the Earth. It showed us that we were part of something bigger. And that's what this total solar eclipse brings for us. It allows us a window into the universe. And this is the most connected, most well-observed event that we've ever had in terms of a total solar eclipse. The data and the experiences are going to be amazing.
Okay, so we're certainly witnessing a monumental celestial and historical event today. We'd like to take a moment to talk about safety. So, Jody, can you help me out here? So,
I will help you out.
You never look directly at the sun, and you may have seen these eclipse glasses, and they're designed with special purpose solar filters. Ordinary sunglasses, even very dark ones, are not safe for looking at the sun. Now, if you're in the path of totality, there is a short time frame that you can take your glasses off. This is only when the moon completely blocks the sun, and that is during totality. Let's watch this video to learn more. Okay, so Alex and Jody, I'm very fortunate that I have glasses, and a lot of people have glasses, but a lot of people don't have glasses.
Yes.
So what are other options? Let me start with you, Alex, on how they can view the eclipse
Well,
safely.
the simplest thing to remember to look at it indirectly is a pinhole viewer. And there's a lot of ways you can make a pinhole. You can take a simple piece of paper, poke a hole in it. In fact, I've got here a 3D map of the path across the U.S. with a hole in it that I can use as a pinhole to project the circular sun down on the ground, and then you can see the moon move across it. As a matter of fact, anything with holes, including this colander, is something you can use to look at the eclipse. But you can also use something a little more sophisticated if you want.
So you can actually make a box. You actually just do 2 holes in one side of the box and then put white paper on the inside. Then put aluminum foil, do a hole in the middle, not too big, that you can actually project the sun inside the box. Make sure that the sun is actually behind you so you can actually look at it inside of the box. It will be an amazing projector.
Okay, so before I toss the social, I gotta do this because we're on the College of Charleston, and College of Charleston students, make some noise! That's what I'm talking about. Okay, so the social media world is going to break records. So let me toss to my man, John, on the social front. What's going on?
Thanks, Dwayne. There are literally millions of people watching this broadcast right now. We're going to be monitoring the conversation online and taking your questions as a total solar eclipse treks across the United States. There's a tremendous amount of excitement online, and we want to share with you at home. So we will show you images of the eclipse from your unique vantage point. Submit your pictures and questions using the hashtag Eclipse2017 and follow the conversation online. For updates, be sure to follow, let's see if I can remember all these, NASA on Facebook, Twitter, Tumblr, Instagram, Snapchat, and LinkedIn. Additionally, we're providing live coverage during the eclipse on Facebook Live on NASA's Facebook page. You can ask your questions in the comment thread. Check out their streaming sites like NASA's Periscope account on Twitter, Twitch TV, Ustream, and on YouTube. And of course, you can watch it on Nasa.gov and Nasa.gov/Eclipse Live and on the NASA app. And we have a special feature for you. If you visit our Facebook Live page, along with this broadcast, we have a 360 view from right here in Charleston, South Carolina. With this tool, you can pan around on your computer and mobile device and even look up to the sky as the moon transits the sun during the eclipse. It'll be like you're right here with us in Charleston, minus the sweltering heat. Visit the NASA Facebook page and check it out. And finally, share your images of the eclipse with us using the hashtag Eclipse2017 on our Flickr page, which is up here online right now. Share your images with us, and we'll share them right here in the broadcast and also on social media. And finally, enjoy your eclipse viewing, and remember to ask your questions with the hashtag Eclipse2017. Back to you, Dwayne.
Well, John, it's social media is going to break some records, and we're going to be coming back to you more and more. So you got to know that one of the most important things here for today is the weather. So, Sean, you know, I'm looking at Charleston skies. We got clouds. I hope that's going to get better, but what's going on around the nation? Over to you.
That's right, Dwayne. Yes, the weather is the key factor for viewing today's total solar eclipse. Right here in Charleston, it's about 86 degrees, but with the humidity, it feels more like 99 right now. But what we want to do right now is show you a satellite image from our friends at NOAA, the National Oceanic and Atmospheric Administration. This is from the GOES-16 satellite. It's a brand new weather satellite that NASA built for NOAA and was launched last year that's going to give you the latest and greatest, very detailed imagery of cloud cover across the country. And what you can see is that things are looking really good for the early parts of the path of totality, places like Oregon and Idaho and Wyoming. And then as you get into parts of the middle section of the country, more places like Beatrice, Nebraska, maybe into Kansas City, Jefferson City, there is some cloud cover there that may hinder your ability to view the eclipse. And looks like as you get into Carbondale, skies are still pretty good there. There are some storm systems developing to the north in other parts of Illinois. And really, things are looking clear again until you get back here in Charleston. As you said, Dwayne, I'm looking up at the clouds to where the sun will be in about an hour. And there is significant cloud cover, but we're keeping our fingers crossed. I do see some pockets of blue in there. So hopefully we'll get to see something. But we'll have more for you later in the broadcast. Dwayne.
Thanks, Sean. Hopefully you can use some of your connections to get us some good weather here in Charleston. So the moon is already moving across the face of the sun. We're getting close to viewing our first total eclipse of the day. We're minutes away, and remember, the total solar eclipse starts on the west coast of the United States in Oregon, and we will be bringing you live images as it occurs. NASA's Ames Research Center's Jesse Carpenter is standing by in Salem, Oregon at the Oregon State Fairgrounds. Jesse, give us a status report.
Oh, wow. Thanks, Dwayne. Totality is almost here. Oh, this is so exciting. And just before we get to that, though, I want to introduce Andrea Edgecombe again from the Oregon Museum of Science and Industry. Hey.
Hi.
So tell us a little bit about this really fun, cool viewing event that's going on here.
Yeah, well, we are here. We have almost 9,000 people here at the Oregon State Fairgrounds, and we've had some cool stage presentations. We heard from NASA astronaut Don Pettit. He's an Oregonian. We had a University of Oregon professor, and behind us we have some space science partners who've been doing some cool educational activities and really interacting with the crowd. So it's been an awesome morning, and we can't wait for totality in a few minutes.
This is such a great event. Thank you for joining us again. We really appreciate it. I know you got to get going.
Yeah,
so
thank you.
It's coming soon. And joining us now to talk to us about the sun and give us more information is NASA lead scientist for Eclipse 2017, Madhulika Guhatakirta from Ames Research Center. Hi, Lika.
Hey, Jesse.
Hey, it's almost here. It's almost here. So how many eclipses have you seen?
I went to see 9 eclipses, and I actually landed up seeing 6. The other 3 had inclement weather.
Oh.
We don't have that here today.
No, we don't, and it's going to be 7. So what can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now, and whatever I say, kind of take it with that filter, because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. Corona is the region where space weather is born and conditions are set for a supersonic solar wind and a super hot corona, 2 of our outstanding questions in heliophysics, in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now, how coincidental, called Parker Solar Probe. It is actually going to go touch the sun, and it's going to get closer to any other spacecraft has gone before to the sun to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, just now coming in, we have an exclusive sneak peek of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view.
Wow.
And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon, where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
That's so pretty.
That's the G3 there. Is that the real thing? Is that the real? We're going to keep that up, and then we're going to do reactions. Okay, so
as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got? That looks pretty cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, you know, Sean, and, you know, get that weather up here looking good here in Charleston. Now, what do we...
So, Alex,
Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright, actually the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So, Alex, a reminder, Alex, so when that diamond ring pops up, that's what people should put the
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the origin. That is where the origin of space weather.
Yes.
You know, that's where it comes from.
That's where most of the solar flares and the corona mass ejections, big explosions of particles, originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's the diamond ring again. That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that, and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods, because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juiced. I mean, they got it. They got the goods.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
gasping.
Completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're gonna see something like this today, and you saw it. But you're gonna see it better because nature does it better than we can actually do it artificially. Right now, the activity is there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you see on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls?
Absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird we have a crescent sun instead of a crescent moon. This is I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago, and things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official did, and we went with him to a place, a school in Southern California. Take a look. It talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website, look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a Solar System Ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime. But is that, as a scientist, you see it as an opportunity?
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on it.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going on.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation? All right, and watch, and we can talk. All right, so we still, just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth's sunline is tilted by 5 degrees, and so there's only 2 places where the moon and the Earth and sun are on that same line, and that's why every 18 months or so we get an eclipse. 1 minute away. Wow.
The crowd is getting excited.
Wow. It's already so eerie.
Wow, it just got dark all around us. And you can feel the temperature getting colder here.
Oh, yeah. The winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can, it's just a tiny, tiny sliver right now. It's all closing up.
There it goes. It's going. Getting smaller.
Oh my gosh!
Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh wow!
There's Venus. Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah, wow. Wow.
We should turn off the lights.
Go where? Look. All right. You get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on around
the street
us.
lights turned on.
We
Of course.
confused the street lights.
Of course. Who would have thought that? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay. There it goes.
That's the moon. Oh, look.
There's
Stand
the diamond
by.
ring. There's the diamond ring.
Oh my gosh.
Yeah. Wow.
That is
Was
so.
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
Well, it has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Well, Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So, Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Okay, so we're gonna come back to you and we're gonna talk about what's happening here. So the next up, NASA's ready to take a bite out of the Big Apple, one of my favorite cities, Jotty, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm gonna turn to you, New York. They're going to get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Abukan, the Research Administrator for the NASA Science Mission Directorate. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
And we're back here at the G3 up over the Pacific Ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years, I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about 2 things. First of all, the shape of the corona. You know, I saw the models. I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you can turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? Well, it's hydrogen. Well, so even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
Yeah, so it was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. And as we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains, but it was all the darkness, and it was just stunning to me to see that. So really, really good stuff, and I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed, some fantastic images we've already looked at that I can't wait to share with everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows? What?
Okay, all right. So now let's go to the NASA Marshall Space Flight Center. Chris Blair standing by.
Humans are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us more is Dominic Critchlow from Austin Peay State University. Thanks for joining us. We appreciate it. So tell the crowd and our audience a little bit about the scientific payload you have on board.
Yeah, thank you for having me. Today we're flying some still image equipment, and we're going to be taking images of the ground in different wavelengths. And we're also flying live streaming equipment, so we can live stream the eclipse looking downwards and looking around, and at 100,000 feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA AIMS, and then our trackers so we can have a successful recovery.
Okay, and they've just released your balloon, so let's talk about the NASA science and the biological samples. Explain more.
So NASA AIMS has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool.
We are very excited about that. And so also, how many balloon releases are you planning on doing this today or this weekend?
So all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have a full coverage of the stream. And on the site today, we have 3 launches from 3 different universities. And we're just really excited to be here and hopefully all successful launches.
All right, so finally, these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country? What's a tip you would tell them?
If you find it, leave it there. Maybe take a picture because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it.
Awesome. Thanks. We appreciate your time.
Thank you.
Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
Well, the students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the